I'm welcoming all the participants here, and thank you for taking your time. And and thanks for your I just completely believe you get lots of exposure here. Yeah. Next, moving on to introducing. So here we have Rania and Jen. So quickly introducing about Rania. So she's an applied AI scientist, and Rania, she has over 7 years of experience in the industry, and she holds a PhD degree in computer vision and artificial intelligence from the University of Montreal. And at present, Rania is working at Bentley on several projects related to defect detection in infrastructure assets such as roads, bridges, and etc. And prior to her current role, she served as a computer vision and AI scientist at Ultra Electronics, where she contributed to the development of, ID document scanners and falsification detectors design, which is for to use by global border control agencies. And in addition to her professional pursuits, Rania has an academic experience as a lecturer, for many computer science courses at University of Montreal. And yeah. Here I feel very honored to introduce Rania. Yep, let's welcome Rania here. And yeah, just now I'll quickly introduce Jen as well. So from then I'll leave on to the stage for you both. Yeah, so now introducing about Jen, she's a product manager, and Jen, she holds a bachelor's degree in electrical and electrical engineering, and she has a master's in optics as well. And Jen began her career in the electro-optics as a sensing specialist, and she began her journey into AI and ML as a systems engineer at Allworks, and specializing in ML and IoT technologies as well. And currently at Bentley, Jen spent several years with the applied AI team, helping to build and integrate AI capabilities into solutions for, construction, transportation, and energy products. And as a product manager within the, iTwin products groups, Jen is working to integrate AI or ML workflows to leverage user data and bring additional value to our users operating and maintaining infrastructure. Oh yeah, I'm really feeling so honored, quickly talking about you both, what you're doing currently within the industry, and I'm eagerly excited, to hear more from you, and our participants will get more wisdom from you both. Yeah, here I welcome you both. Yeah, please, I can share your insights.
Great. Just before we start, I just want to make sure everybody sees the screen share. Yep. Okay, well, thank you very much for having us today. Thank you for the introduction. So today we're going to talk about building an AI products for societal impact and a holistic approach. We're already 15 minutes within the hour. I hope we have enough time to cover everything and also have a Q&A at the end. So just going to here. Oops, let me know. There you go. So this is Rania and I. I'm based in Quebec City, Rania. I don't know if you want to quickly say where you're based. Oh, the unmute doesn't work. She's based in Montreal, but we'll have to get that unmute working later on. You also have an access to our LinkedIn pages if ever you want to connect with us later on. So I'm just going to go ahead. So what is Bentley? What do we do? So if you think we're making cars, that's not it. And we're not making handbags either, right? So we provide innovative software to advance the world's infrastructure, sustaining both the global economy and the environment for improved quality of life. So what does it mean, really? So we do software for civil infrastructures. Right? And we're really big in this concept of digital twin. So what is a digital twin? You have the physical assets, right? So right now you have buildings, you have a bridge, you have roads, you have parking lots. You also have the river and the grounds. And then what we do at Bentley is that we create this digital twin. So the digital information of your physical asset. And that can be done through different types of data, right? You have maps, you have reality data, 3D models, sensors and everything, but I'm not gonna go into details. I'm going to show you a little excerpt of a video that kind of quickly introduces the concept of digital twins.
Our company has been very, very involved in the idea of digital twins, of having computer models that replicate what's physically out there in the field.
So I hope everybody had the sound, yes? Yes, excellent. And then you also have a little QR code if you want to see the entire video. I'll also show other excerpts. So really, it's basically having the digital information of your asset on your computers, right? Again, we're going to talk about product management in this presentation too. Product management is about, making a product. Often we only think about the technology, right? So we have a digital twin. I'm only thinking about the technology, but there's more to it to have a product that people will actually use. Everything comes from the book Inspired by Marty Kagan. So if you're into product management, I saw that you had a presentation on Friday as well on it. I highly suggest you read this. It has different series, different books in the series, but Inspired would be the first one. And the entire book focuses on 4 aspects or 4 risks that you should evaluate within your products. So the first one is user value. The other one is feasibility. The other one is usability and business value. I'll go through them. And in this presentation, I'll go through them really like in a linear way, but really through your process, you have to continuously reevaluate these 4 risks and always have them in mind. So it's not a linear process, right? Like I'm going to be showing you, but it's really something about, reevaluating everything you do within those 4 risks. So the first one is user value. So it's really important that you don't start with, I have this technology, I want to make a product out of it. What you have to do is, what are the problems the users are facing, and how can I use technology to help them overcome these problems, right? So if you don't start with that, you're kind of going backwards, right? So in our case, we're going to talk about bridges. So infrastructure is something we don't really think about in our everyday life, right? We just cross across one shore to another without really thinking about what is involved, right? For bridges in this example. But when those bridges or infrastructures fail, they fail big time. And that's when we think about them, right? For example, when it can isolate communities. This was an example in after a hurricane, I think, in Puerto Rico, entire communities were just stranded on islands and had no access to medication, no access to food, because really the bridge had collapsed and there was no more communication and no more ways of getting goods to the community. Other times, this was an overpass here in Canada in 2006 that collapsed, and it had, people died from this collapse because cars were going on this overpass, and these are also some terrible consequences. And maybe a bit closer in time, it can have, environmental effects too, where this train was carrying a highly toxic material like asphalt and sulfur that spilled into the river after the bridge collapsed. So what do we do to prevent those? We do bridge inspections. And I'm going to be showing you a little video of how this bridge inspection is done today.
I was reading through a magazine and saw a picture that was kind of grainy, black and white, and showed several men, bridge inspectors, on ropes hung over the side of a structure. So that picture had been taken in 2013. It looked like it was from the 1960s. We've got to be able to do better.
There are currently over 20,000 bridges in the state of Minnesota. It's important to keep on with the inspections so that we can properly maintain them over the course of their life and find out when the need is to replace them.
We started partnering with Bentley because both of us really wanted to use technology to improve the inspection workflow.
Most of those engineers don't go out in the field much, so it's hard to relay through close-up pictures and trying to explain to them what I'm seeing.
So sorry, it cut a little bit short. If you want to watch the whole video, again, you have the QR code. But a couple of things I want to mention about this video. They said there's 20,000 bridges in Minnesota. There's actually 600,000 bridges in the United States, and it's aging. About 42% are over 50 years old. So you have to make sure that all these bridges are in working conditions and, be able to prevent accidents like we just saw by doing, routine inspections and maintenance. She also said that at the end, Jennifer says, the people don't go out there and they don't have the information. That means that the decision makers, the one that say which bridges are going to be repaired, they're not out on the field. They're in their offices. They get all these PDF reports, pages of pages. They have to read through them and they have to decide which bridge gets the money or not. And that's crucial because you don't want to skip a bridge just because the report was poorly done, right? So this is where we're thinking, oh, sorry, before I go there, I do want to stress on how we do the inspection today, right? So we have, the people have to go on site. Now this one is under a bridge, so it's not that dangerous, but often they have to close down lanes and cars go by really fast and they have to assess the bridge condition. They often use paper and pencils to write down, and they have to do this written report in PDF. They will often join pictures, but sometimes it's still hard. So for example, in this crack, they still have the picture on the right-hand side, but then they'll draw the cracks to have a better view. And still, I mean, it's hard to convey this information. And when you go back in time 2 years later, you have to say, hey, did my crack get worse or is it still in the same condition? And that's really hard to do with these drawings. And there's more than just cracks, right? There's cracks, and then there's lots of, you want to know the length, the width, the depth. Sometimes there's condition like water seeping through, doing efflorescence. You have spalls. Spalls are concrete that is just falling off the surface, and there's corrosion. So even in this example, like, there's scaling where the corrosion is actually like eating through the metal and exposing those holes. So these are the things that we're trying to find to make sure that we assess the bridge's condition. And going back to what I was saying, well, if we have a digital twin, probably we can have AI/ML help with this. And this is where we go to the second category, which is feasibility. What can AI/ML do to help? This is where I'm going to hand it over to Rania, and I hope her mic works. Yes.
Yeah, I believe it does. Do you hear me?
I do.
Okay, perfect. Yeah, thanks, Jen, for the introduction. That leads us to ask a few questions about how can AI model help in this kind of situation in order to detect this kind of defects. And before answering the question, we need to address few issues before to make sure that we have all what we need to answer, to build actually an AI model. And one of the main things that we need to consider before starting is, do we have enough data? When we talk about AI/ML, data is really the center problem or center question in there. So in this case, any data scientist need to ask, okay, well, I need some data to build a model on that. And in general, if you can see this kind of flower in here, it's a sort of AI life cycle. So the first thing is the data creation and acquisition. In our cases, in general, data creation is not is the job of the clients, the users. They need to provide us some images. And in general, when I mention data here is technically images. And we need to gather this information from a lot of DOTs and use it later. So, and that's not enough. So yes, we can acquire data, but we need to answer questions whether we have the rights to use it. So we need, I'm gonna show it probably in the next slide, but let me cover this first. So there is all the legal questions that need to be addressed as well. when all the questions related to data are addressed, answered, now we can think about, yeah, so let's start to experiment. Let's start to think based on what we have and what the problem we are facing. What are the most appropriate models or architectures that we can apply to this problem? And let's run a training, and then we have some results out of this training. Let's evaluate them using, again, some appropriate metrics, appropriate, yeah, appropriate to the problem and to the models. I'm going to explain this later. And and then if we're happy, actually, before we go to the deployment, the evaluation, I mentioned metrics and tools, automatic tools to evaluate the model, but there's also all the feedback from the client. We need to ask the client, okay, well, here's the performance of the model. Are you satisfied? What do you think about it? Because, and I'm going to go through that later. So there's the evaluation step, which is automatic, and then based on the client feedback. If we are happy, everyone is happy.
Oh, you cut off. Rania, you cut off. We can't hear you.
Yeah.
Do you know?
She's in the call, but yeah,
Yeah,
it's got cut off.
so I think, do you know if your headset got moved to a different
Do you hear me? No, I saw your message.
No, we don't hear you.
Mm.
No, we don't hear you. So you hear us, but you don't hear, we don't
Yeah.
hear you. So I don't know if, yeah, if you could check with the mic. While we're waiting for Rania, I don't know if anybody has questions up to now.
We have two questions, a question in the chat. Yeah.
Sure. Could you, I don't see the chat right now.
Do you hear me?
Oh yeah,
Sorry.
we hear you.
No,
Okay, we'll go back to
another-
Rania then.
Oh my
Yeah,
God, I'm so sorry. I have another headset that decided to take over mine.
No
So
problem.
yeah, I don't know where did you lost me? Did you hear me talking about the model development evaluation?
Yeah, you can start there.
So what I was saying is that I'm gonna go real quick. So we have data. Based on that data, we label it, obviously, and then we build a model. The choice of the model really depends on the problem, what we're gonna want to build on the data also. So this is the job of a data scientist, to pick what's the most appropriate architecture of a model that may apply best to our problem. And then it's a cyclic it's an iterative process. So we train this model, we evaluate it, we see how it performs. That's based on automatic metrics. In general, we choose metrics that apply the best to the model, to the architecture and the problem. So again, metrics and model choice should always be appropriate to the problem and the images, the data. And if we are happy with we use these metrics, we evaluate, we see the results. It's in general numerical results, but we also need to have the feedback of the client also. So we provide the results and we ask them, okay, how do you think about it? How do you feel? Is it good enough or not? And we reiterate. So if they are happy enough with that, we can deploy it and we retrain. So that's kind of gives an idea about how what is the cycle of an AI model. Can you go next, Jen? Okay, so here I'm going back to talk about the data, and how, I already mentioned how important it is. And we think about it like, okay, we get some data and then we use it. Well, actually, in reality, there's all the legal sides that need to be addressed, because in general, in our cases, we are not the owners of the images. So we don't have the right to use them right away or train models directly. We need to have some data agreements with the owners to provide us, to grant us actually the rights to use that information. And since we, in this case, when it comes to bridge inspection, since we are using outdoor images, there's a big question about GDPR. about anonymization, because in some cases, when it's images taken by drones or automatic cars or whatever, there are chances that we capture, these images have some faces or some license plates. So before using these images, before labeling them, we need to make sure that they are fully anonymized, right? That's really a very, very important and critical step to make sure we go through it. Yeah, can you go just next? Okay. I mentioned that we are not the owners of the data in general. The images, we get them from a lot of DOTs and departments of transportations when I say DOTs. And in general, we found out that we have, in general, two types of images. There are the drone taken images, as you can see on the left image. It's image taken from really far. And there are the inspection images, which are some defects that are taken from really, really close. And in general, there's an expert or engineer that he's inspecting and checking whether, for example, in this case, a crack is serious or not. And sometimes they use tools for that. So these two information are really, really very different. So let's talk about cracks, since this is what we have here. You can see that on the right image, we can see clearly the crack, while when it comes to an image taken by a drone, well, good luck, because first of all, the resolution is not, first of all, the image is taken from really, really far, and second, it's not really the resolution is not really made or appropriate to find cracks. In general, when we have images taken with drones, the main purpose of the DOTs is to build a 3D model based on these drone images, and we reuse these images to look for defects. So sometimes it's really challenging when it comes to finding cracks. Like, for example, we are not sure if is this a crack or not. Good luck when it's time to labeling this data. So yeah, it's challenging when it comes to drone information, but we're happy because we have some inspection images that are gonna leverage, that's gonna augment data and help the model to have various sources of information. That makes it robust when exposed to different types of images later. Next, Jen. Okay, so we have data, we're happy with it. We're gonna label it before using it for our AI model. Well, before starting labeling, we need to understand what to include and what not to when it comes to defects. So that takes a lot of discussion with the clients or experts, actually, engineers, to explain to us what to include and what to exclude. It's not always clear. Maybe here, when it comes to the spall, that part of concrete that broke down, we can see it clearly. But in the image, in the lower image, the bottom image, actually, good luck to know what to consider. If you can go back, Jen, just to see the cracks without the highlights, well, you see that in the top left side, we can see that there are very thin cracks, but we have no idea whether they are worth to be included or not when it comes to labeling. So that takes discussion with clients and ask them, hey, what do you think about it? Should we include them or not? And they will, yes, say yeah, we need to find any type of cracks, whether it is serious, large, or really, really thin. Again, and then the last image is, as you can see, an example of corrosion and rust. And again, yeah, some parts are really clear that there is some scaling and serious corrosion, and some spots are really, really tiny dots that we don't know at first when we first look at this problem, whether, again, we need to include it or not. So see, when it comes to data labeling, it takes a lot of knowledge and understanding before. And there's that. And there's also the second point, which is what to use to label this information. Bounding boxes, always we think about bounding boxes because it's easier, faster, you draw a box and you go next. But when the client asks for information like, okay, well, I need the area of that spall, or I need the length or the width of the crack, etc. Those extra information, the bounding box would not provide that information. So that extra information that the client requires helps us to decide what to use as a tool to label this information. So in this case, we need to do a segmentation because we have no choice. We need extra information, right? So yeah. Next, Jen. We went through data collection, data labeling. Now we're ready to build some AI models. Again, as I mentioned before, this part requires a good understanding of AI for sure, and because it's important to right away select what's the most appropriate model for this kind of problem. Now, in this case, and we actually experimented two main classes of architectures of AI models. There are the CNN-based models and the vision transformers models. And we experimented both of them for the three types of defects we are working on, and depending on the defect, I mean the accuracy of the model later. In some cases, CNN models were best fitted for some kind of defects, for example, for the cracks, while transformers were more fitted for spalls and rust. So this takes a lot of experimentation to understand what's better for this or that case, right? So yeah, as I said, for now, we are providing three separate models. So one model per defect. But it doesn't mean that we cannot provide one model for everything, and the output's going to be, okay, well, I detected a crack, or I detected a spall, or even for example, rust, we can use a whole general model that finds subclasses of rust. I didn't take time actually to explain that, but we can have, exposed rebars when we have a spall. And yeah, so in some cases, actually, it's a mix of everything. You have a defect, it's a spall, and under the spall you have some exposed rebars that are rusted, and you have some cracks going outside of that spall. So yeah, that's something that needs to be considered too. Sorry if I talk fast. Can you go next? Yeah. So here we provide the few results from the models that we having right now. So so this is the original image. You can see that in this image we have a mix of everything. So we have cracks everywhere, and that's actually very interesting because yes, we have cracks, but you can see that we have these thin lines, like vertical and horizontal lines, that in reality, these are not cracks. These are like kind of the way the thing was built. I don't know what it's called, honestly, but you can see that it's not really cracks. So one of the challenges of the crack detector is to differentiate a crack from these thin vertical or horizontal lines. So that's important. So you can go next, Jen, to show when we apply the crack model on this image, it kind of finds really the cracks and kind of isolate them from the lines I was showing. And in the same image, you can see that we have spalled and we have exposed rebars. So if you go next, so here we applied the spall detector. You can see that it detected pretty much the spalls it sees here. And we also applied the rust detector, and it really detected the exposed rebars in this case. You can see in the lower rusted rebars, it kind of misses some few spots probably. And actually, this is when I mentioned the evaluation of the model and the feedback of the user. These things actually need to be discussed with the client to see, hey, at what level you need us to provide, at what precision, what we call precision and recall, when it comes to an AI model. Sometimes we don't need to go really like overkill. Sometimes they want to find the big, let's say, for example, they want to know the severe conditions of cracks or spalls. And when it comes, for example, to some spots of rust, they're like, okay, well, maybe you don't need to put that much of energy on that. So see, evaluation with metrics and automatic evaluation, it's really important, but the feedback of the user is way more important. So we can go next to explain that. So in our cases, since we are using segmentation and not rectangles, we need to think about few. Here I am providing some state of the art when it comes to evaluating a segmentation model. So there is the semantic segmentation and instance segmentation, and the main difference is that when it comes to instance segmentation, we suppose that here we are detecting shares. When it comes to instance segmentation, we need to find them separately and say, okay, well, we found share 1, share 2, share 3 separately, and we compare the ground truth to the detected shares. While when it comes to semantic segmentation is that we don't care, we only want to find shares. Okay, so in our case, we technically, when it comes, for example, for spalls, maybe we don't need to call them spall 1, spall 2, and we only want to find spalls. So in our cases, we thought that semantic segmentation is going to be the most appropriate solution. And this is important actually, because when it comes to evaluation, I'm not going to go really, I know the purpose is not to go very technical, but we don't want to miscompare share 1 detected with share 2 in the ground truth. Even though we both detected share 1 and share 2, if we compare them, then the score is going to be low, even though we detected both of them. So this is why semantic segmentation might be better in our case. We can hit next. You can hit next. Yeah. Again, so here an example where we are detecting spalls, and the first image is the original one. The second one, the one in the middle, is the prediction of the model, and the one on right is the ground truth. So what labelers draw and thought as spalls. And overall, you can see that the model is doing a good job. It found the spalls, but when you look at the edges, you can tell that, okay, well, maybe it's not perfectly, it's more smooth at prediction compared to the ground truth. And when it comes to providing the metrics, these details makes the score maybe a little lower when it comes to the accuracy of the model. While if we provide this information to a client, he or she might be happy with that. I mean, what they want to find in this case is not really perfectly the edges of the spall, but to find those spalls, right? So yeah, this is why the feedback of the client is really, really important and should be done in continuity, actually. Okay, so we built an AI model that's doing a good job when it comes to cracks or spalls or rust or corrosion. But what's the final product we're providing? See, when Jen talked about the product, and the problem in reality is to go to send an inspector, an expert, and go on the field and all the complexity. Well, what's the alternative we are providing? Well, technically is to provide a 3D scene or 3D mesh, actually. And on top of that, we apply our AI model, and we show all of those lines. As you can see, in this case, it's the crack detector. And you can see here on left, we have the 3D scene, and on the right or on the bottom, we have all the related images to that scene. And this is what we want to show our client. Hey, this is a better way to actually address the problem. So that's pretty much it. That's the final result we are providing. So so that's about feasibility. Hope I didn't take.
Just going to mute here. So yeah, Rania just went through feasibility. We're able to do AI detection on 2D images and reproject them in 3D. It's feasible. So or the next step is usability, right? So we were so happy. We were able to provide the users with 3D. So we went back to our users and said, look, you can run the AI and the 3D in this one software that we have, and then you can have the overlay. This is great. You have a 3D navigation. It's geolocated. You can see them. You can also hide them because they're vectorized. Ain't that great, right? But then the user says, well, maybe I'd like to have the measurements for each one. Well, we said, perfect. Well, look, if you import the results into the second software, now you can have the measurements for each crack. Isn't that great? Like, right? You have all the, now you know its length. And then the user then said, okay, but look, all these false positives, I don't want them. I said, well, using the same software, you can just select them and then you can remove all the false positives. And for example, these cracks, and then you can even select them all together. And then in the second software, you can do that. So we were showing this to the user, and we're just going to wait for this to finish. But then the user said, okay, this is great, but oh, sorry, before that, we're showing that now you have all the right cracks, so you can compute the total length of the cracks, and it's perfect for your reporting. But then the user said, well, what if I want this crack is not long enough, and what if I want to change each individual crack? So we said, oh, well, you can just do this in this third software. So look, you can edit it, make it, a bit thinner if you want. You can also make it longer if you want. So you're not just removing the false positives, but you're also correcting the measurements. And then they said, well, what if I want to see it through a severity scale? Like if my longer the crack is, it's more severe. Well, in this third software, you can do that too, right? Now we're color coding with severity, and we're showing that, the long cracks have a certain severity and the other ones are. But what do you think happened when we showed this? And we were all excited to show this to the users, right? Did they say, well, this is great. It did what they asked for. But they had 3 softwares to go through. And all these software are desktop software. So everything is locally based on your computer. Nothing is on the web. So if I want to share it to somebody, that somebody else has to have the same suite of software. And, I have to transfer those big files. How do you think the user said, well, they said, well, I can't use this. So even if we have the technology and we're providing them with what they need, it doesn't work in their workflow. So we went back, and it took us, more years to provide this, but this is what we came back with. And this is the i20 Experience platform. So this is all web-based. So let me go in the video. Oops. Let me show it. Sorry, paused. So this is the software. So now you have not only one digital twin, but you have all your assets. So that goes back to wonder how I can support local communities with, I'm just going to pause it here. Before we go, I'm just going to go back here. So one of the person asked, I wonder how we can support the local communities do long-term asset management. So this is where it comes in, right? Where we put all the information of all the assets that you have in your network and you put it in. So all the green flags are digital models, and all the blue ones is the past inspections that, those PDF files that I was telling you about. And then you have them all into one software, and because it's web-based, it's really easy to share with different people that are decision makers. So as we go in, now you can go in within your asset, and this is where you have your 3D model of your asset. Again, you're able to share that with your users. With your colleagues, the ones that make decisions. So you have your inspectors, but also like the maintenance crew. So now everybody has access to this 3D model. And I'm just showing you how, it's on the entire span of it, and you have really good, quality. But you can now also do something, not just view it. You can also put in flags of defects, right? So either you do this inspection before you go, so you do it in the office, or once you're on site, you can also have an iPad and you can enter this information. And now you have all this information, and it's really easy to share, right? So we're adding in functionalities to make it work within their workflow, and we can only do this by working with them. Now you can also run the AI on these on the web portal. So now you don't have to have a virtual machine, and you can do it on a virtual machine, so you don't have to be local. And now you have all these cracks, and then each crack has information. If we look at this one has a certain length, certain width, and it's automatically has a severity scale. But not only that, now I can add that crack, and not just one, but I could do multiple, and then add some issues like we were showing on the other side. And as we do that, that creates an issue, and then that creates the inspection report, right? So now we're really putting everything into one platform, so it's usable. So we went back and we asked, how would you use it? How do you use it? And then with the user feedback, we provided them with this solution, right? Okay. So we went through user value, feasibility, and usability. Now, I'm not going to go really in details. We only have 7 minutes left, but obviously there's business viability. So how much would you charge? How would you charge? And how much does it cost you to do it? Because obviously we're here to make money, right? If you're not making money, or you have a deficit, your business or your product is not going to be used, right? So obviously I'm not going to go in, but there's different ways you can do to, iTunes, you used to be able to download for 99 cents a song. Now we're into streaming. There's different ways you can also make money with the same product. So so you have to think about this. So these are the 4 product management risks that you have to always keep in mind, and always go back and reassess every time. So I did want to show a video, but I don't think we're going to have time. So please go scan that QR code and see what it's about. I want to have 6 minutes maybe, so we can answer some questions from the participants. But check out this video. It shows you how the users were able to, use a platform, and how it changed the way they were doing things. So we were able to fit it in. Yay. Any questions? I see some maybe in the chat. How do these 3D models update in real time? So they don't update in real time, meaning that they're drone captures. So you fly drones, and then you take images of the entire asset, and you make sure that you have overlap. So one point has to be seen by 3 images, and it's called photogrammetry, and it reconstructs in 3D. So you will have that 3D model at a certain time when you flew the drone captures. However, you can add IoT data, so sensors, and you could have that real-time feedback if you have sensors on your model, but not the 3D model itself.
If I can add something about this question, because
Yes.
as Jen said, it doesn't really update real time, but actually there is a possibility of update through time. So when we talk about a bridge inspection, there's the possibility to retake, in 1 year, let's say, for example, another we fly a drone over it again, and then we do the inspection, and in that way there's a possibility to see the evolution of the cracks or the defects in general through time. So that's also actually might be possible to consider. So
another question we have is, what are specific use cases and challenges you're dealing with? To be more precise, are CNN used in your CNN-based model? Oh, you're on mute, Rania.
Sorry, I was multitasking. The question was, thanks for what are the specific use cases and challenges you're dealing with? Yeah, there's a lot. For example, to be more precise, is faster RCNN used in your CNN-based model? It was okay, I'm gonna start with the second one because it's gonna be faster. It was experimented. It's not the result we are showing is not out of faster RCNN, honestly, but RCNN was experimented on this problem. And to be honest, RCNN and faster RCNN were conceived, let's say, for a detecting everyday objects, much like, for example, outdoors objects in the street. They're really, really good at finding that. But when it comes to more specific problems, they were experimental. They were doing good results, but they're not the model that we picked up finally, because we experimented other models based on ResNet, obviously, and they provided a better accuracy. What are the use case challenges? I mentioned few ones when it comes to labeling the importance of understanding. There is the quality when it comes. The main part of images we are receiving are drone-based images, and the resolution sometimes is really not what we hope we have, because when you are dealing with cracks, you need high resolution to see them, mainly when it's thin cracks. So yeah, we sometimes deal with some challenges of this type. Yeah.
The other question was, if there are more cracks after a year of inspection, is there a new 3D model created, or there are changes appended to our previous model? So there's two ways to do this. Usually you would redo your model. So in the United States, it's 2 years in between each inspection. So 2 years later, you would go back with your drones and create a 3D model. And then from the two 3D models, then you can do change detections. But the other way is also, there's things that are called crack meter. So you can add sensors within cracks, and these sensors are connected to the cloud. That information is power. I didn't show any examples, but these sensors measurements can be pushed to the platform, and you can set alarms, and you could be able to see it in real time. Maybe not see it, but you can see the measurements in real time of that crack meter, and you'd be able to see its evolution over time. There's only 1 minute left. I do want to. Oh, did you want to add something, Rania, on that?
Yeah, I would like to cover one question. I believe we did not address it, which is from the head. She's saying, I don't understand why semantic segmentation is better than the other method in this case. I'm going to give you an example. Okay, suppose we are working on the cracks, and as good the result may be, as we can see, sometimes it's really, really hard. So sometimes actually a long crack can be detected as 3 sub parts of it, 3 sub cracks, right? Because in some cases it gets really thinner, and the model is having a hard time to find those thin parts, you know? So it detects, let's say, for example, 90% of the whole long crack, but as 3 separate parts. Now, when we go with the instance segmentation approach, this approach will address these 3 parts separately as separate instances. So when you compare it to the ground truth, which is 1 long crack, you can take one of the thirds, let's say, and you're going to compare it to the long one, and the score is going to be really like, whether it is recall or precision or whatever, it's going to be low because of this. So this is why semantic segmentation may apply better in this kind of problem. So yeah.
Excellent. We're up to time. I'll hand it back to our host. Thank you very much for having us today. We had a blast. Please reach out to us on LinkedIn if you have more questions. You can also put them in and DM us on LinkedIn.
Yeah. Thank you, both of you. Thank you, Jen, and thank you, Rania. Like this is really very insightful presentation on building AI products for societal impact and ROI. And yeah, we don't have time, but quickly to address a few 1-2 crucial points. It's like, your emphasis on the urgent need for better inspection methods, like for over 600,000 like aging bridges in United States, was really, I feel like eye-opening. And you have been shared about the challenges of manual inspection. Like you have effectively highlighted the limitations of current manual inspection methods, including their lack of precision and high cost. That's really a key takeaway. And the innovative AI solution, like you have introduced, you have been introducing an AI-based defect detection system, like using drone technology and 3D imaging presence. Like that is a groundbreaking approach, I can say, like to enhance safety and efficiency. And definitely this has really a great impact on future generations, I would say. Your vision of, using AI for sustainable infrastructure and the, preservation of bridges for future generations is both inspiring and forward thinking. And thank you so much for, again, for sharing your expertise and insights with us today. It's really helpful. Thanks for sharing your wisdom. Yeah.
It was a pleasure, and good luck to all of you, and have fun during the hackathon.
Yeah.